Welcome to UMA's weather station analysis first week of observations. I am focusing on February 5th through 11th, 2023. My station is at 864 feet above sea level, and it's located just uphill from Farmers Loop near the University of Alaska Fairbanks, or UAF. I'm comparing my station data with the National Weather Service station at the Fairbanks International Airport. I'm sharing a photo of the really beautiful snow we have this winter, remember, compared to last year when we had the big thick layer of ice, and a photo of moose at our compost pile on what was a really beautiful morning, Tuesday, February 7th. The pressure at my station is shown in green, and that from the airport is in red. I plotted the pressure in both inches mercury and hectopascals. They look quite similar, which is a good thing. The week started out with pressure decreasing and reaching a minimum of around 980 hectopascal on the 6th of February, after which it increased to a peak late on the 8th of February of about 115 hectopascals, after which it decreased. Pressure variations are so smooth compared to the other variables, and I must say I prefer hectopascals to inches mercury because there just isn't enough difference in the inches mercury. It went from a minimum of 29 to a maximum of 30. Just doesn't seem like that big of a difference to me. This slide shows temperature and dew point for my station at the top and for the Fairbanks Airport at the bottom. The ups and downs are really similar between the two stations, but I noticed that the difference between the 2-meter air temperature and dew point at my station seems to be smaller than that at the airport. The airport, the difference between those two lines seems a bit bigger. The temperature and the dew point are close together on the evening of the 6th and early on the 8th at my station, hinting at clouds and precipitation. The warmest temperatures were on the 6th, reaching into the 20s Fahrenheit, and the lows were on the 10th, between the 9th and the 10th, of up to 15, 16 below Fahrenheit. The radiosonde profiles for 3 a.m., which is 12Z, and 3 p.m., which is 0Z the following day, for both the 6th and the 8th show the largest differences between the dew point and the air temperatures on the 6th. You can see those two lines are far apart. And then on the 8th, they're much closer together, which generally agrees with what my temperature time series are showing. It also shows that on the 8th, it was cold at the surface, and there was a strong temperature inversion in the 3 a.m. plot for the 8th at the bottom, and not as strong on the 8th in the afternoon, which makes sense. As the day warms, that temperature inversion starts to break. I had to include my solar radiation data because it's amazing how much it's going up each day. It struck me that it was interesting that there was a lot more solar radiation on the 6th versus the 8th. Even though the 8th had high pressure, it must have had clouds, which kept the solar radiation low. And it was much warmer on the 6th. So maybe that does agree, but maybe my sensor on the 8th was covered with snow. That was a day I wasn't in town. But again, it leaves some questions that I don't have the answers to right now. So let's look at some weather maps. This is from the afternoon of the 6th from the National Weather Service Anchorage office weather map pages. And on the afternoon of the 6th, there was a series of low pressures going, hugging the southern coast of Alaska, moving across the southern coast of Alaska, and some of which penetrated into interior Alaska. In fact, there was even thunder snow reported in the Wrangell St. Elias. And if you've never heard thunder snow, it's big booms of thunder during a snowstorm. It's quite interesting. On the 8th, the synoptic pattern was a bit different. There was a low pressure pattern in Western Alaska on land, but if you notice, the low was a fairly high low. The pressure isobar there is 1,014. So remember, we had pressures of 1,015 maximum on the 8th. So much higher pressure over all of interior Alaska. You also see there were a big storm in the Gulf of Alaska, much farther south. They weren't as close to the state. And as you get into the afternoon weather on the lower plot, that generally very far space between the isobars, which keeps the winds relatively low during the day on the 8th. Next, let's look at the infrared image for the 6th. Were not downloaded because I forgot. I need to do this manually because they go away. But I was able to get some help, and I downloaded the plot on the right, which is a movie from the NESDIS webpage. You can actually go back a few days, and I was able to go into their directory and download this data. So on the 6th, you can see some clouds forming. Again, they're not as high. They're blue level clouds, so they're quite a bit warmer than the green clouds, so they're not as high in this infrared image. I'll stop that. We'll go on to the next. On the 8th of January, again, the still image of the IR suggests less clouds than on the 6th, less high clouds. There could have been low clouds, which we can't see here. And then the color IR loop supports this. So let's look at this loop. And this is a loop that runs between 5 a.m. and 2 p.m. And the loop in the previous plot was 5 a.m. to 1 p.m. This actually looks cloudy. Next, I want to compare relative humidity. This plot shows the relative humidity at the home station in blue and at the Fairbanks Airport in purple. They really look quite different, and there are large dips each day in the home station, which you can see that happens sometime in the afternoon. You don't get them every single day, interestingly. And so that made me curious, so I made another plot. So here I have plotted relative humidity in blue with the right-hand side y-axis going with relative humidity, and on the left-hand side, is the y-axis for temperature. So I put the temperature and the relative humidity at the home station together. And what you see is that spike in daily temperature corresponds to the relative humidity sharp falls each day. And this is a great example of what we're learning this week in chapter 5 about relative humidity. So I'm pivoting here to discuss the equation for relative humidity. Relative humidity is the actual water vapor in the atmosphere, that's E, over the saturation water vapor, E sub S. The curve on the right is a figure from chapter 5 showing the saturation vapor pressure as a function of air temperature on the x-axis. At higher temperatures, the saturation vapor pressure is higher because warm air can hold more water because before it reaches saturation, meaning the maximum that it can hold is higher. And the saturation is the maximum that any parcel of air can hold. And when it goes above that, the water vapor goes from gas to liquid. We say it condenses. And then lots of interesting things happen, which we'll talk about late in next chapter, I believe. Back to our picture here. The amount of absolute moisture around my station does not really change in this short period of time. You're not having a big air mass blow in. So E in this equation of relative humidity stays the same. But when the temperature goes up quickly, then E sub S also goes up. So now you're dividing by a bigger number at the bottom, and so you reduce the relative humidity. And you notice that the relative humidity goes back up again as the temperature drops. So again, a nice example of looking at the data and applying what we learned in class. So let's these are the loops of the weather patterns on the 5th, again, and then on the 8th, whoops, click, you can see the lows were hugging. This is the 5th, so it doesn't get all of the lows because I didn't have the data for the 6th. The lows on the 6th, 5th and 6th were hugging farther south. There was generally low pressure over the state. And then On the 8th, the lows were much farther south, and there was generally high pressure over the state, and that agrees with what I found at the station. So let's summarize here. These are my take-home points. My deeper dive focused on the 6th and the 8th, partially because I picked those days because there was the lowest and the highest pressure of the week, so it would likely show the most contrast, but you can choose many different criteria. For the most part, my weather station matched the Fairbanks Airport station. I'm not that far. It was particularly close in terms of tendency, meaning the direction it's going. It was going up, it was going down together. The temperature and dew point were higher at my station than in the weather service. I'm several 500 feet higher than the weather station, than the Fairbanks Airport, so you'd expect the temperatures to be warmer. And therefore a bit more humidity. The sea level pressure was slightly lower at my station than the airport, which again makes sense because I'm a little bit higher, but it seemed to follow very closely. My station relative humidity looks different at the airport than at the airport, and the decreases seem to match the warming during the day. Again, I have to think about this some more. I don't know that I fully understand it. And then the comparison of February 6th, which was a low pressure day, and February 8th, a high pressure day, highlighted the differences in the large scale circulation. And the satellite IR maps for the 5th, 6th showed more cloudiness than on the 8th, but these images were not simple to interpret, and it wasn't just a very clean answer. So again, there's a lot of subtlety and a lot of complications, and you also have to look exactly at the same hours. So again, do your best when you're doing this. And so now I'm going to go off weather presenter character, and I just want to give you some off-screen comments as you prepare this. I spent a lot of time on this. I started doing this on Saturday, and then I kept making more plots, and I kept looking at it, and it really helped me set up the folder with all the plots that you can use. Again, don't make it as long as mine. Mine kind of, I went off the rails here by making it too complicated. So keep it simple, keep it to things you're comfortable with. Maybe pick one thing and explore it in the time you have. One thing I did is I made a simple story, and then I kept adding more plots because I had questions about the data. So that's a good way to build out your story. You won't always have all the info that you want, so just make do with what you have. At first, I didn't have a script, so 2 days ago, I started doing my videotaping, and I kept stopping and starting because I kept messing it up. And then I wrote out a script, because then I focused on exactly what I wanted to say, and it was much faster, and it was much easier in the end. I didn't have to keep retaping it, so I highly recommend it. Sometimes you want to save time by not making a script, but some people are good at that and they don't need to make a script, like weather forecasters. I'm always impressed, but they're also trained to do that. I also went too long, but it gives you an example on a variety of things that you can explore in your data. And I will try to dig up some past examples. Thank you for your attention.